This is more of homework set 37. Question 11, let's write this, let's compact this into one single logarithm. It's already expanded, let's compact it. So one single logarithm, log, now there's no base, so just leave no base, base is 10. But now, as I look through, I don't see any minus signs. So I'm not going to write any fraction bar. If I saw a minus sign, fraction bar right away. Everything that follows the minus goes on the bottom. But we don't have any of those, so we're only going to have numerators. Now, I have an x times a y, right? It's a plus. Additions come from multiplication. So I'm going to have an x and a y, and those multipliers out there become the exponents, right? The multipliers came down from exponent. So it is going to be x to the 1/3, y to the 1/4. All right, that's probably good. Or you could do this. You could leave it as the log of, say, the cube root of x times the fourth root of y. But probably this one right here, that's probably better. Now here in question 12, we have two minus signs. So whatever follows the minus, the y and the z, that's going in the denominator. So write this as one single exponent. So no base, so soon to be a 10. So I'll just write log. Now, as soon as I see that minus, fraction bar. Now, the positives go on the top. So x on top, y and z on the bottom. But look at this, I've got a multiplier, so bring that up as the exponent. So on the top, we'll have x to the 1/2, and the denominator, okay, I got a 4, that'll be an exponent, and a 4, that'll be an exponent. So we are going to get y to the 4th and a z to the 4th. Question 13. Right as a single logarithm, and first thing I notice is I've got a minus. So this is going to be the log of, now fraction bar, right? And on the top goes the positive one, x squared minus 16. Now I know that'll factor, difference of two squares. And in the bottom, look what we have here, a multiplier. So that's going to come up as an exponent. So I'm going to have quantity, x plus 4 squared. Now, let's factor that top. So we're going to get the log of x plus 4, x minus 4. Oh, see it? That x plus 4 squared, we can cancel, right? So I can cancel that one on top with one of these on the bottom. And here's what we're left with. We are left with the log of x minus 4, right? That's all that's left on the top. And 1x plus 4 on the bottom. Question 14, let's solve this equation. Now the first thing to do is write this expanded form as compacted into one single logarithm. So how about this? It'll be the log base 6. Now I don't see any negatives, so no minuses, so no fraction bar. So I have a plus, that becomes a multiplication. Now x times 4, but I'm going to write it as 4x. That's all equal to 1. Now, logarithm is the exponent, right? The logarithm is the exponent. So the exponent is 1. Exponents go on a base, so this is 6. So I get 6 to the 1 is equal to 4x. That's just 6 equals 4x. Let's divide by 4. We'll get x equals 6 over 4. Or how about x equals 3/2? Question 15. Let's solve this logarithmic equation. And I notice this is plus, so I'm going to add, I'm going to multiply these together, right? There's no minus, so no fraction bar. So how about log base 4 of x times x plus 6? That's equal to 2. Now, the logarithm is the exponent. So the at 2 goes on the 4 as the base, so we'll get 4 squared equals, just multiply it, x squared plus 6x. So how about 16 is equal to x squared plus 6x? Now it's quadratic, right? It's quadratic. I got a squared term. I know how to solve these. Get everything on one side, 0 on the other. So let's subtract that 16. So we will get 0 is equal to x squared plus 6x minus 16. Let's factor. So we'll get x and x. How about 8 and 2? 8 and 2. Now I want a plus 6 here. So how about plus 8 minus 2? Now, I get two solutions here. I get x equals negative 8 and positive 2. However, be careful. These are just potential solutions. I need to check because the properties of logarithms, here's what happens. When you take the log, any base of a logarithm, whatever you put inside there has to be positive. So we have to be sure that when we put these numbers, negative 8 and 2, into that original expression, we get the log of a positive, log of a positive. Now, right away, can you see, if you use x equals negative 8, okay, if x equals negative 8, what do you get when you put that negative 8 in here? Okay, in that case, I will get the log of a negative number, all right, no way, all right, so that is out. Negative 8 is not going to work. But what if you put in the 2? What if x equals 2? Okay, then what happens is if you put the 2 in here, right, I'm going to get log base 4 of 2 plus log base 4 of 2 plus 6. I want to know, is that equal to 2? I see what I did here. You see what I did? We should have had a 4 here, so I need to make those 4s because that was not working. All right, so this is going to be log base 4, log base 4. You probably caught that. And then what happens? Log is the exponent. So 4 to the 2, right? 4 to the 2, 4 squared. If I can get this to right, 4 squared is equal to 16. That works, all right? So here's our solution. X is equal to 2. Thought we had 2 of them, but we had only 1. And that ends this group of problems here in homework set 37.